Officially now, I'm taping. Here we go, rock and roll fans. We're talking about a thing called composition of functions. And for those of you who are new to me, you're going to realize that while I seem like a complete and total idiot, I'm only partially an idiot. I do actually know the math, and I know how to teach the math way. So we will learn it the math way. But I also feel like sometimes understanding things is easy when you have perhaps an analogy to help you. So in a few moments, I'm going to give you the actual definition of composition of functions. It's an operation. It's something we do to functions. And I'm going to explain it to you the math way. But I think when you see the math definition, you're going to be like, what the holy heck? That doesn't even make any sense. So let me tell you what we're doing in the Mrs. Tarantino way. What we're going to be doing is taking a thing, a number or some letters. We're going to be putting it into a function, right? That's taking a domain and putting it inside a function. That's what we've been doing. We're going to get an answer out and take that answer and put it into a new function. When you do that, that's called composing. And I want you to think about it like this. It's like taking a cupcake that you want to take home. You don't want to eat it there. And what you do with that cupcake is you put it in a box, right? That's putting your domain into your function. And now you have a nice little cupcake in a box. That's going to now go into the bag, right? We do that all the time in life. We do that all the time. We do that with our feet and socks and shoes, right? We take our feet, and we put them in the socks, and we put them in the shoes. We compose a little function there. What's important to note is that order matters, right? You can put your shoes on first and then put socks on. Weird and strange, and people will make fun of you. It is possible. You can dump the cupcake in the bag and then throw the box on top. Don't really know why you would do it, but you can. You can also put more than one thing in the box. So you could have bought a cupcake and a cookie. That's supposed to be like a chocolate chip cookie. You can't really see my little dots there. A chocolate chip cookie. You can put both of those things into the box and then the whole thing into your bag, right? That's what we're doing. So from here on out, I will say we're going to compose these functions. We're going to do function composition. But sometimes if you look at me like, I don't remember what that is, I'll say, the cupcake thing. And you'll be like, oh, I got it. Right? So here comes the actual definition. Now, this looks like a lot to write down. It's not. Here's what I want you to write down. I want you to write this word down. Let's make that nice and big so you have it. I want you to write this on your paper. We're talking about the composition of functions. And I'm about to give you a definition, but it doesn't fit in that box nicely. So if it helps you, you are welcome to think, oh, and look, that's me. That's me with my little calculator. I'll stand over here. And it's the cupcake rule, right? So there's my little cupcake sitting there. Okay? And I am going to give you the actual definition, right? Composition of functions looks like this. You know how when we do multiplication looks like this. Don't write this. Like if we did f times x, f times g, that's timesing. We could go f plus g, that's adding. We could go f divided by g, that's dividing, right? Let me show you what composition looks like. Composition looks like one of two things. One makes total sense. One doesn't make any sense at all. One way they write it is they were going to write it like this. Oh, I don't want that. I want blue. They're going to write it like this. Okay. Right? If you see things like that, that's going to be telling us to do composition. And I'm going to give you the definition in just a second. They also write it in this crazy way. And instead of using this, which makes total sense to me, they use this weird new symbol that you don't see very often. It's not an O, it's a big fat dot. And here's what's crazy. Your Algebra 2 trig book or Algebra 2 book did it like this. The pre-calc book does it almost exclusively like that. What do I do on the homework? Because I write it myself, I learn about, right? So I don't want you to be like, what gypsy magic is that? Like it's not. It's just another way to write composition, right? So here's the definition, and the definition is this. Okay, and it's going to seem crazy, but then we're going to think about it in terms of our cupcake stuff. So here's what it's going to say. When you have the composition of functions, and I'm going to say, here's the example of what it's going to look like. Okay, so you write this, means, here's what it means. The range of G. I hate that noise in a movie theater. Like I hate, like it looks like don't eat things that crinkle. Like for the love of God, like in a movie theater, it's like put that away. And I almost cussed that. Oh, every time on the stupid tape, the range of G becomes the domain of F. Now, what a lot of my colleagues do is they just end it there. It's like, see, that's the definition. And if you're like me right now, you're looking at that thinking, I have no idea what that means. And let me tell you what it means. It means when you plug in and get an answer for G, right? That's your range. That's now what you plug into F. It becomes the new domain, right? So really, this is the fancy way of saying, take the answer for G and plug it into F. And we go backwards. We take our first dude, plug it into G, plug it into F. Does that make sense? And you have to go in that order, right? If I wanted to go the other order, I'd have to do it like this. Could I do that? I absolutely could. But it matters, right? It can often give you two different answers, right? So you got to be careful on it. What if it's written in this weird, funky FOG way? We go backwards. We start here, go to this dude, go to this dude. Are you cool with that? So let's start with something nice and easy. Nice and easy. Welcome to Algebra 2 again. So let's start nice and easy. Here it is. First one we'll start with. Okay. That looks all crazy. Well, maybe, you know what? Yeah, can we start here? It's going to look a little easier. It looks crazy and scary, but it's not. All it's saying is this. It's saying take your domain of -7 and plug it in to this dude right here. Can you do that right now? Nice and easy. Take the -7, plug it in. Shouldn't be scary. -7 times 2, -14. So did you get like -12? So let's think about what we're saying. We're saying this is my X. This is my Y. Is everybody cool with that? That's my domain. That's my range. Now my answer for this dude right here, the answer for this dude becomes the new thing that I plug in to that guy. Does that make sense? So the range of the first guy becomes my new plug-in for the next guy. So I take that -12, I plug it in. Super easy. 3 times -12 plus 5. I'm going to get -36 plus 5. Oops, already did that. So did you get like -31? Yeah? Does that make sense? That's not bad, huh? So I want you to try one. I want you to try one on your own. Here we go. Try this bad boy. Oh, it's written in that weird FOG way, but that's our G of H way. That doesn't matter, right? It just means you go backwards. You're going to take that 10. Be careful. Plug it in the H first. Plug it in the G second. Order matters. So if you did it the other way, you'd come out with a different answer. It wouldn't be wrong. It would just be for a different problem. When you get an answer you like, there's no rush. I don't expect you to have it right this minute. Share it with a neighbor. See if they agree with you. See if you're the smart one or the pretty one. Remember, if you get it wrong, you're probably better looking. That's how that works. I love composition. It's fulfilling to me. So here's what I'm going to do. I'm going to take that 10. I'm going to plug it in right there. So I'm going to get 35. Now my answer for this dude becomes my the guy I'm plugging in here. So 4 times 35, That's 140, in case you wanted to know. Take away 2, I got 138. How'd I do? Did I do okay? Can you wiggle your fingers if you got that? Nice and easy? No one losing no? Yeah? Are you with me? Okay. So that's algebra 2. Algebra 2 trick. We start plugging in. What if we don't plug in numbers? Right? We love numbers. Numbers are fulfilling. What if we just plug in letters? Can that still work? It can. It's a little stickier, but we can make it work. So let's take a look at this bad boy, right? Here's what we're going to do. We're going to just pop out the N and put in a new letter, right? That's all we're doing on the first one. So everywhere we see an N for H, we're not going to call it N anymore. He's got a new letter, right? We're just going to pop that in. This is called writing a rule, because it's not going to have like a 7 as an answer. It's going to have variables. We don't always like that because it kind of pisses us off, right? So that's our first step. We just popped out one and popped in another. And now the domain, or the range of the second guy, the first guy, now we're going to pop him into here, right? Remember, we're popping out N and we're putting it in new. For those of my friends who want to see it a little clearer, what we're doing is this. G of 3x equals 4n plus 5. Everywhere we see an N, we're popping out that N. We're putting this dude in its place. And we're going to say 4 times 3x plus 5. Oops. Yes. Don't forget to do, oh, sorry, that's not right. There we go. Plus 5. We're going to make 12x plus 5. And if you're like, Miss T, that's unfulfilling. I can't do anything more. You guys ready to try one on your own? Okay, here we go. Take a look at this one. Can you do that one? Nice and easy. Nothing scary. Relax. Hopefully some of you are like, I kind of remember this. Others of you are like, Christine, this is terrifying. I hate this video. I hate it. I hate sitting on top. Just reaching for it. And sticky. It's sweaty. Sticky. As always, as I'm walking around, can you share your answer with someone? See if they're as smart as you, right? If you're like trying to peek over their shoulder, see if they got the same thing you got, right? Nice. Like that response. Very nice. Like that. So I'm just going to pop out this X. Get out of here, dude. That's all I had to do for the first guy. Nothing that hard. But now on this one, be really careful. I'm plugging in a lot of stuff here. Be careful on your distribution here. 2x plus 3 minus 4. We got to do a little bit of baby distribution. 10x plus 15. Take away 4. Plus 11. Am I good? Let's see what we're doing on the next one. I think the next one gets kind of crazy. It does. Okay. Hello, pre-calculus. Now we're pre-calculus. And here's what I'm going to tell you. We got some claw happening here, right? We got some claw happening here. Because we're going to, the first step, look, you don't even have to change the letter. It's so easy. It's like, with the C, it's already an X. I'm like, yeah, so you don't have to do anything. So if you plugged in X right here, you're just going to get 5X plus 1. I gave you a nice, easy start. But here's where this one's going to get a little ugly. We're going to take this action, and we're going to plug it in here with a squared, and here with a 3X. I'm going to be quiet for a few minutes, because this one might take a few seconds. There are 2 of these on your homework total. But let's see how you do on this one. This is a men from the boys question. Here's a little hint for you. It's going to be 5x plus 1 squared, and we have to write it twice. Little claw action. And then don't forget the 3 has to do a little baby distribution too. You got Got some chunky math there. I'm going to give you a minute. You got this, you got this. It doesn't get hard. Nice. Nice. Lovely. Lovely, 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 lovely. 25x, right?
Yeah.
Yeah.
That's what I got.
Plus 25x.
Plus 24.
Nice. Nice. 25x squared. Yeah. Plus 25x. Nice. Damn. Nice. Pre-calc's nice. I've never given this class up. Nice. Nice. Hey, wow. Freaks, weirdos. So here we go. Little claw action. 25x squared. Plus 5x plus 5x. I just heard Jay say that for me. It's like he's a plant. Plus 1. Hey, don't forget 1 times 1. 1, not 2. Don't forget this guy. 15x plus 3. We're going to do some combining of like terms, right? Everything that's got the same last name. That's x squared. I got 25 of those bad boys. There are no other x squareds, so that's that dude. Now I'm going to count up all of my x's, right? That's called your linear term. There are 5 of them, and 5 of them, and 15 of them. So a total of 25 of those bad boys. And then finally, the last thing I'm going to combine is just my constant numbers, 1 and 3. That makes 4. Nice, nice. We got 2 last things to do, but it goes easy, right? That was the top. We go downhill here. We're going to take, real quick, I'm not going to do this one. Hey, this is a crazy one. You got one of these on your homework. I love this one. And it's like, what? What kind of gypsy magic is this? Here's what it is. You're just going to get your answer and plug it back into itself again. Now, I have a hard time seeing this, so you know what I do? I just write a second one of these up here, right? I just write it up here a second time. So guess what I'm going to do? I'm going to put in my M, get my answer, put it into F again. So that's called composing with itself. It's a cool little thing that it can do. It can just, you could do a million of them. It just keeps going inside of itself. It would like be putting on if you're putting on like a billion jackets, right? You put on a sweater, and then you put on a coat, and then you put on a raincoat, and then you put on a parka. Like that would just be layering, right? You can do that. I want to get through this. So the last thing I want to talk about is sometimes we put both the cupcake and a cookie in the bag, and that's okay, right? That's okay. That doesn't freak us out any, right? So I don't want that to scare you. So if we see something that looks like this, you know what I'm going to do? I'm going to change this problem up. I would like everyone to put a little 2 right there, right? We're going to make this problem a little bit thicker because I think it was confusing the way it is. So here's what we're going to do. We're going to take our cupcake and our cookie. Here it is, our cupcake and our cookie. Both of those are going to go into this guy, right? Are you cool with that? So here we go. Let's start there. 2 times a plus 2 minus 3. Did I lose anybody? Everyone feeling like they're okay with me, yeah? So I'm going to get 2a plus 4. Nothing scary. Take away 3. 2a plus 1. That is my range. And now I'm going to take this dude and plug him right back in here. Is it hard? No, it's fine. I just didn't want you to freak out when you saw like, wait, it's not just a letter, it's a letter and a number. That's fine. Just shove them in there, right? So I'm going to go ahead and say 4 times 2a plus 1 minus 2. Give everyone a breath to catch up with me. And next week, we get our second board, I think, so it's going to be very exciting. 8a plus 4 minus 2. 8a plus 2, right? Lovely, lovely, lovely. The last one I'm going to show you is my favorite, and you're going to look at it, and when I show it to you, you're going to be like, what? That seems so hard. And then when I show it to you, you're going to be like, I love these problems because they are my favorites, and I love things that are easy. So here we go. Look at this crazy mess right here, and you're like, what? What am I supposed to do? Love this. It requires no math. You have to be able to count. So here's what we're going to do. We're going to do what it tells me to do. And here's what it tells me to do. It says, take your 2 and go to the F graph, right? And plug it in on the X just like we did 2 nights ago. So we're going to go to this dude and we're going to see what his answer is. And you know what his answer is? His answer is 5. Did I lose anybody how I got that? Is everybody cool? Watch this now. Now what we do is now we have to go to the G graph. We're going to take, oh, come back, little 5. I'm going to make this work. We're going to take, please work. We're going to take that little 5, I'm a genius, and I'm going to plug it in over here. Does that make sense? Because he's now the X for the new guy. And now I feel like, okay, who does he match up with? He matches up with -6. So easy. No math. Does that make sense? So I started, so I took my 2, went to F, got my answer, took that answer, did it again, and then got the new answer. Does that make sense? So you're going to try it now while I pass out your homework. Here's the one I want you to try. You're going to start with 4, but we're going to start on G first, get our X, our Y answer, and then Y turns into our new X. Does that make sense? Give it a try. Just take it. Eyeball it. Talk to your neighbors. See if you can do that. I like this. It looks scary. It's super not scary. Give me 2 seconds to count it.
Okay. So take the 4 to the teacher, and then call it out.
I think it's a up,
down 1. Yeah, and it's -1.
Is it -1? And it's just the final thing is the I know. Okay, so here we go. Last one before I tell you what you're going to do your homework, and I check out homework and I give out free homework assignments. So much to do. So here's what it's going to look like. So here's what it tells me to do. It tells me to take my 4. Really? Stop that. Take the 4 and start on my G graph, right? So I'm going over the G graph and I'm going to 4 right here, and then I find my new Y. And my new Y, that's -4. And now I'm going to use him to flip over to my other graph, but we start fresh again. We start fresh. So we go to -4 and we see where he matches up, and it's right here at -1. Does that make sense? Here's what's cool. You could, if you were some kind of crazy monster, you could keep on doing this like forever and ever. You could take that -1 and hop back over and find out that it's at 6. And you could do it again and again and again. And why we like function notation is that's so much faster than writing out like 10 problems. Here's your homework. Here, let me talk to you about it real quick. There are 20 problems. I think I need you to do about 17 of them. You can skip 3, but don't be a baby. I want you to try those last ones. They seem trickier than they are. Here's one I want to say. I know I've got about a half and half class in here. If you're a junior, there's a good chance you're going to try to take an AP class next year, either AP Stat or AP Calc. If that's you, you need to be getting through all these problems. You can do that. If you're a senior, let me give you a smart piece of advice. The first class that counts for college math when you get to college is pre-calculus. So my advice, take this class, ace it, go to college, retake it. get your first college A, right? So that would be my advice to you. So if you're a senior and if some of this is a little tricky, no harm, no foul. Number 4 and number 12, those are the claw ones. If you don't want to do both of them, pick one, don't do the other one. And that's what I have to tell you. I'm going to give you all your free homeworks. If you have pictures, could you make a little doc and email it to me? It just makes me happy. I'm going to print some of them out and hang them around the room because they make me happy. So we're doing that. And I am turning off my videotape. And I am checking off